One is October 2024, Unit 6. So in the question, a student investigated how the current in a diode varies with the temperature. As you can see, the student varied the temperature of a diode from a room temperature to 100 using an apparatus shown. So he is having a hot plate, a water is there, a diode, a beaker, thermometer. Identify one health and safety issue and how it should be dealt with. So what is the safety issue regarding, like, as you can see, the hot plate, it will be hot. So like hot plate, definitely it will be hot, so it may cause a burn if a person touches that hot plate. Then when you use electricity in a damp condition, then there might be a chance of a short circuit. So that is also a possibility. Like example, if I use electricity in a moist condition, then there might be a chance a circuit might be short, or electricity might flow through a least resistive path. So a short circuit could happen or occur in this case. And so how we can avoid a short circuit? Short circuits are avoided by using insulations, proper insulation and a tight connection and a proper insulation can. The main drawback is like beaker might be hot, water might be hot, or hot plates are there. So the student connect the diode in the circuit as shown. A 100 ohm resistor is there, a diode is there, a 1 kilo ohm resistor, and an ammeter. He uses an ammeter to measure a current as he varied the temperature of a diode. Explain why a student was correct to include a variable resistor. Look, what is the main purpose of using a variable resistor? Because because a diode does not need a high potential. Diode need a very low potential to work, like 0.7, 0.8 volt. So, and we are investigating how the main objective of the experiment was what? The main objective is how a student varies like he's investigating how the current in a diode varies with the temperature. So if we change the current in a diode, if we change the temperature of a diode, how the current will vary. If let's say if there was no variable resistor here, if there was no variable resistor here, then what will happen as the temperature of the diode changes, its resistance will also change. So means as a only two components are there. As only two components are there, if the resistance of a diode is decreasing, so the voltage across the diode will also decrease. So if the voltage is changing, that will also have an effect on the current. But we are investigating how the current in the diode is related with the temperature. That is our investigation. We know it's inversely proportional, but if if we were not having a variable resistor, the voltage across the diode will also change as its resistance changing. So what is the purpose of the variable resistor? Like let's say we did at like 0 degrees or 10 degrees. So the voltage here might be 3 volts, voltage here is 2 volts, voltage here is 1. But when we increase the temperature, so the resistance of a diode will change, so voltage across diode will also change. So we adjust a variable resistor. So we adjusted the variable resistor, so the voltage division will remain same. Like if there was no variable resistor, then if 2 volts here, 4 volts will be here. If 3 volts here, 3 volts will be here. If 4 volts here, 2 volts will be here. So voltage across the diode will also change. So main purpose of using a variable resistor, so its resistance can be adjusted. So the voltage across the diode remain constant as we are investigating how the temperature affects the current. Not otherwise, because the voltage can also affect the current in the circuit as well. Is it clear? This one? Part B. Next we have part C. In part C, the student predicted the variation of a current with the temperature would be linear He recorded the following results and our data and plotted a graph against the temperature and the time, a temperature and the current. Explain whether the units of the current in the table is correct for this data. If you see, the current is about like a very high value is there, 9 ampere, 6.3, which is showing that it's representing a very high value. So it means, but we have to state, and if you see the total resistance of the circuit, if I have, let's say a diode does not have any resistance. So this is 1000 and this is 100. So the total resistance of a circuit is 1100. And we have the formula V is equals to IR. So what is the current, maximum current in the circuit? That is the voltage divided by resistance. So voltage is 6 and resistance is 1100. So 6 divided by 1100, I'll get like 0.0055 ampere. So means the maximum current, if the diode was having a zero resistance, so the maximum current in the circuit could be, that is the maximum current. Current will decrease if the diode resistance increases. But if the diode does not have a resistance, the current should be like 0.005. But student values are wrong. Like as you can see, that it's taken in the range of 9 ampere, 6.3 ampere, which is very high, unrealistic values. So table is not correct because the maximum current in the circuit should be 0.005 ampere, 55 ampere, which is much lower than any value which is shown in the table. Give two reasons why this data cannot be used to test the student prediction. Because student is saying that there's a linear relation between a temperature and a current. So why this data? First, you can see only 3 sets of results are there. Like we don't have if just we measure from 29 to 50 with a 3 sets of a result, or a range of a temperature is very low, the range which we use. So, or we don't have enough values to plot a graph, only 3 values are there to plot a graph, which will be difficult to estimate the line of a best fit. We need more data and a greater range for a temperature to work out, a better graph to show a relation between a current and the time, temperature. Question 2, a student investigate the free oscillation of a mass spring system using an apparatus as shown. The student displaces the mass downward and allow the mass to oscillate. So the mass will oscillate, as you can see. She's use a stopwatch to determine a time for the mass to complete 5 oscillation. Determine the mean. So we need an average. So to get an average, we will add and divide it by the total number. How many results are there? 4. And all appear in the same order. So we will not, like if any of the values appear to be anomalous, let's say one of the values 7.11. So that looks out of order, we'll ignore that. But in this case, all looks in the same order. So we just have to add them and divide it. And we need the mean value for a time. So first we'll find the average time period. How to get an average time period? We'll add and divide it by 4 because 4 results are there. No, 7.69 is not out of order. It is 10% range is there. The rule is that it's a 10% range. Like percentage difference. Percentage difference is the maximum minus minimum divided by mean into 100. If you're not sure, maximum minus minimum divide by mean of the number into 100. If the percentage difference is more than 10%, you'll ignore that value. But you will find it's not more than 10%, it's less than 10%. So you'll add and divide it by total, like divided by 4 to get the average of the 5, and then divided this is the time for the 5 you need for 1. So to time for the 5 divided by 5, you'll get for 1. Because we need the mean time period, T. Determine the percentage uncertainty in the mean value. how we determine the for a group data. For a group data, what is the formula for uncertainty? First, uncertainty is a maximum minus minimum divided by 2. And how to get the percentage uncertainty? Percentage uncertainty is a uncertainty divided by mean into 100. And we need in a value of a t. So how it could be done? You can find the uncertainty, because the uncertainty in 5 is same as percentage uncertainty in 5 is same as the percentage uncertainty in 1. So maximum minus minimum divided by 2. Maximum value is there, minimum divided by 2. You'll get the uncertainty. And uncertainty divided by mean, but don't put mean t here. Put the mean of this 5t, because I'm using this data to get the percentage uncertainty. So that's why I will use the average of the 5t. Like add them and divide it by 4. That will be the average. Is it clear? Is it clear, this one? Okay. Next is student measure a time for multiple oscillation and calculated a mean. Describe 3 other techniques you should use to obtain an accurate value of a time period. So if you want to measure a time period accurately as possible, first thing, there should be markers, like, because here we don't have any marker. Like there should be a marker or a surrounding markers, like we can place an object and we put a marker on the object so that we can identify that when it completes its oscillation. So there must be a marker for this, and we should always reset the stopwatch. And when oscillations are there, these all formulas for oscillation are derived for small displacement. Like example, when we talk about even a pendulum, this displacement from a mean position should be very small so that it will obey the law. Otherwise, if it's a large displacement, then the formulas are not applicable on that. So what we should do, we should place a marker behind this to identify that it's mean and the extreme positions. And we should always have a small displacement and reset the stopwatch. Is it clear? Then a student modify the apparatus to investigate the damp oscillation of a mass spring system. She places a circular piece of a card between the masses, act as a damper as shown. The amplitude, devise a method to determine the time taken for A to decrease to half of its value. Your method should include a suitable graph. So we have a graph. A is equals to A naught minus lambda t, where n is a number of oscillation, lambda is a constant. So if I take ln both sides, ln A is equals to ln A naught e to the power minus lambda n. Ln A is equals to ln A naught plus ln e minus lambda n. If we rearrange, ln A is equals to ln A naught minus lambda n, or ln A is equals to minus lambda n. So student amplitude of a damped oscillation vary with the number of oscillations, plus ln A naught. Means this is the equation for us. So what we can do to test this equation, we can plot a graph. What is the investigation? So this devise a method to determine a time for A to decrease half of its initial value. Okay. And so if I need the half of its initial value, I can also say like A is equals to A naught e raised to power minus lambda n. So A naught by 2 is equals to A naught e raised to power minus lambda n. This will cancel with this. So 1 over 2 is equals to e raised to power minus lambda n. When I take ln both sides, now ln half is equals to minus 0.693, and that is equals to ln and e will cancel out, so it will be minus lambda n. Negative cancel with negative, so means lambda is equals to 0.693 over n. This could be the graph value for like a relation is there. So what we can do, we can like two quantities are there. We have cancelled out A. But in this one, we don't need the graph here. So we have to use a first method only. Like the one which I derived first, like I wrote ln A is equals to minus, because the second method is a direct method in which just I have to substitute the value. It will not give the result. So ln A is equals to minus lambda n plus ln A naught. Then what we can do, we can compare with the equation of a straight line. Y is equals to mx plus c. On y-axis, if I have ln A, on x-axis, if I have the number of oscillations, so what will the gradient? Gradient will be equals to minus lambda. If you plot this graph. And we have to devise a method because we devise a method to determine a time taken for A to decrease half of its initial value. I need a time taken by A to decrease half of it. So like first I'll plot a graph and I'll get this value. And then we were having that formula like lambda is equals to 0.693 over n. Where is t here? Determine a time. Okay. So this is giving, I need t. How to get t? T is the number of oscillation divided by t is the time period. So t is equals to n over n divided by capital small t divided by number of oscillation. Yeah. So if I need this t, it will be n into t is equals to this. So what we will do, first we'll plot a graph between this ln A on y-axis and n on x-axis, and that will give us the value for lambda. But even without getting lambda, maybe I missed some point here. Just let me check the question first part. N is amplitude, n is the number of oscillation, a naught is the initial, and lambda is a constant. And devise a method to determine a time taken for A to decrease half of its initial value. Okay, using a gradient, I will get the value for lambda. We got the value for lambda. Then okay, this number of oscillation multiplied by the total time, I'll get, yeah. So this formula also I have to use. So what I have to do, like I have to measure the amplitude of this oscillation and look perpendicular, avoid a parallax error, and like we'll measure the amplitude for a known value of n, like how many value, like 20 oscillation, 30 oscillation, 50 oscillations we'll get for n. And then I'll plot a graph between L and A and on y-axis and N on x-axis. And finding the gradient will give us the lambda. And using a lambda, we'll find an average value of n, like the value of n will get, like using a gradient, we'll get n, lambda, and from lambda, we'll get the value for n. And n is a total number of oscillation multiplied by time for one oscillation. So we'll get the total time it will take to become half. So first we have to determine the amplitude, and we are changing in a graph. Like example, first we do for 10 oscillation, then 20, 30, 40, and 50 oscillation. And using that, we will work out the gradient to get the lambda, and lambda multiplied by using a lambda will find a new value for n, which is an average value 0.693 over n. Like this n is actually the number of oscillation to become half of its original value. So after getting this new n multiplied by time for one oscillation, so we'll know the total time it will take to become half of its original value. Is it clear, this one? Because n was using twice, but one of the n is actually like the number of oscillation, another one is the n when it become half of its original value. So do unit 5 and send your doubts as well. So next session I will discuss that. Unit 5 from October 2024.